I'm Jim Anderton, and this is the Industry Insights and Trends podcast. On this show, we'll explore the length and breadth of 21st century engineering, from civil engineering mega projects to innovation at the quantum level. We speak with subject matter experts and industry watchers from every sector of the engineering discipline.
You know, this decade promises to be a renaissance for American manufacturing. Even before the prospect of tariffs meant that reshoring became an imperative, the reality is that automation and other technology has driven a renewed interest in manufacturing closer to the customer base rather than shipping goods across the planet. I'm joined by Kevin Johnson. He's principal engineer at Digi International. And Kevin, welcome to the podcast to start with.
Thank you, Jim. Good to be here.
Kevin, I just mentioned in my brief intro that everyone's talking about the reshoring and the bringing of manufacturing back to America, but there is a little glitch in that plan, and that is finding the people necessary to actually make this happen. It says, how big is this problem? Are there going to be enough bodies going forward to make this work?
Well, I think the challenge is real. I mean, my perspective is we are going to have to augment that workforce in some way. Right. And the technology that's in front of us obviously is going to be something around AI and automation. Right. And we're going to need to, like, as an industry, come up with solutions for, these manufacturers to solve this problem. And I believe that we have a good start there.
Yeah. Yeah. Now it's my own background's from automotive manufacturing, and that's an industry where it was one of the early adopters of automation. I mean, heck, GM was one of the the founders of Fanuc, one of the major robotics companies. That the solutions there were purpose built, and the production lines were configured around the automation. Very, very expensive way to do this sort of thing. We're looking at a situation for many manufacturing operations where there's systems that are configured for people, but the people aren't there anymore. So in a perfect world, you would have a robotic solution that you could drop in place of a human being in a production process. And there's some debate as to whether or not that is something that is going to happen fast enough to sort of replace the human solution there. Is the robotics in place in a way that we're going to need to solve this as a general purpose way, do you think?
I think yes, but I think there is some additional, like, robotic design, which is not my subject, my subject of expertise. It's really around the connectivity of how those robots communicate and how that interaction happens, right? What we're seeing just really is a transformation of how IT infrastructure is created in these environments. We can't use the hub and spoke, the corporate firewall, the long latency, high bandwidth applications. We need to figure out ways to bring in automation as close to the process. We need to figure out how to do things like bring in edge compute, right? So instead of processing a gigabyte or a megabyte size image file, you're digitizing things and you're processing kilobytes, right? Things that become more efficient. Instead of the guy who has the job to go out to the sensor to go read the display and document it, we need to put a device out there, save the guy 30 minutes, and just automate what that readout is. I mean, there's a lot of things that we can do today, and we have those in place. We can do it right now.
Yeah, I'm glad you brought up edge computing because it's historically in this kind of standards kind of feedback loop that controls everything in manufacturing. It's sensor sends data, used to be analog data, basically. That is then cleaned up and filtered either electronically or in software. Then it's analyzed, and then a corrective signal is sent to an actuator someplace, and we move forward. And if something goes wrong, and it frequently does in manufacturing, of course, the first thing historically people like me would do is we would question the sensor data. So we question, is it instrumentation? Is the instrumentation is it giving me accurate information? And experts tell me that it's one of the ideas of edge computing is that we're going to process more and more of that information at the sensor. So by the time that you get it and you have some kind of actionable insight, you're reasonably certain that it's real. Is that where we're going, do you think?
Yeah, 100%. And here's how you know that it's real and how you can trust the data is you do it often. Your polling time is not a guy that has a checklist that writes the value down, right? It's that goes away. It's automation. It's every 5 seconds you're getting that information, and then you can see trend over time that, oh, this value is changing. Well, I should be able to trust that because it's been that way. It's been the same for a month. And all of a sudden something is different, whether it's, a motor that's cavitating or it's vibrating or whatever that might be that you're looking at in that automation process. So you should be able to trust the data simply based on automation and just the level of automation that we can bring with predictive AI. Like not even have a human eye on it. Just be able to flood a database full of this data, and AI can go and machine learning can go in and say, oh, you know what? There is something. I'm gonna put a little alert on this, and then the guy can look at the alert instead of the you know the mounds of data that would be available to them.
Yeah. Yeah. Now, the process people, for example, as an example I come up with here, they'll do things like run a fluid into a tank, pump a fluid into a tank, and they'll use, say, a level sensor. They'll may have a proximity sensor to sense levels. They might have an electromechanical system with a float in it. They may bounce a laser off a surface. They have a pressure transducer in a fill line, basically. And you could instrument something like that 100 different ways and have a lot of redundancy and generate a lot of information. Or you could turn around and then infer useful data from other parameters. So if you know the sort of the of a flow rate and a pressure in a pipe, yeah, and you integrate that over time, you can pretty much assume how long it's going to take to fill that tank. Do you know where I'm going with that thought? So
Yeah.
the question here is that what's the future? Is it a infinite number of sensors all throwing information at that AI, or are we going to Google the other way and let the AI infer things from a limited number of sensors?
I think we might see a little bit of both. I think it really does depend on I think the industry. Oil and gas might want more sensors because they want more precise data. It might be, warehousing might want a less because there's less things that can go wrong in those types of environments when it's has anything to do with like life safety. So in those environments, I think, whatever they do, between AI and machine learning, they can extrapolate the 5 sensors or the 2 sensors, right? And AI, when they know how those sensors are supposed to be read, right, and they have those baselines, you throw that into a large language model, and you'll be able to get really good information, really good data, and historical data that you don't have to look at until there's a problem and before the problem actually happens, right? You'll be able to get the data. You know what's happening, you know what has to be replaced. That's when you send the guy. That's when that human interaction comes into play between the alert and the resolution of the issue.
The AI-based systems we're talking about here, and you knew this conversation was going to work its way around to AI because every conversation
Yeah.
does these days, it's the flavor of the month. Is that some of the sort of forward-looking people in industry? I'm thinking some of the large European houses in particular have been telling me that one of the things that they hope AI will do, or expect AI will do, is that it will do things like look at an out of spec parameter or unusual condition in a system, then simply go to the planet and look at thousands of other industrial operations that use similar technology and look for a parallel or a similar circumstance that has happened someplace else. And so, if it's an example we're talking about here, if it's an overcurrent condition in electrical resistance heater in a bakery in Taiwan, that may have a parallel that operates for a paint drying operation in Detroit, because the parameters are roughly similar, and you can draw connections and then find solutions to problems which wouldn't be possible any other way. Is that really where we're going to go?
Yes, I 100% think that's where we're headed. Are we there yet? No, we're not. But all the things that we need to have for AI to be kind of valuable, to get to that place where we're not replacing people, we're just not getting people to do those jobs. That is where the value is going to come, and I think the direction that we're headed, with those large language models and that predictive, the Taiwanese bakery versus the laundromat in Detroit, like, putting all that data together, is going to happen. And but what that looks like, um, how it's going to benefit us, would be around the employees that we're probably we're not going to see in these environments anymore.
Yeah, yeah, yeah. Now, one of the questions, of course, about a widespread implementation of AI in manufacturing, of course, is that what people are going to be doing with it. If you think of, say, for example, in the machining industry, originally it took someone with years of experience, a tool and die maker, a machinist, and tactile skills to know how to machine a keyway in that shaft. Then we went to a CNC world where that individual had that knowledge, but also began to program G code and would actually program lines of code to tell a machine how to do it. AI, we're potentially looking at a world in which we're going to turn around and say, machine a slot in that shaft, and then it will take it from there and actually program the machine as well. So what about the level of expertise necessary from the individual who's on the shop floor? Are we still going to need the kind of skill level that we used to have?
So, so I would change that. I think yes. I think at some level we're going to need those experts, right? But at some level we're going to become better, and we're going to have more precision in that manufacturing process because AI is going to take over certain elements, right? Including QA, like the QA process of having high definition cameras to go in and analyze, was this machined part? Is it to 100% spec? Yes. We're going to get to a place where fault tolerance and the QA process is really it's going to be very impressive, especially with we have a lot of new manufacturing facilities that are headed towards the US. Yeah, we're not going to have the bodies, so we need this kind of automation, and quality control is kind of the most exciting thing for me because it's going to be exact. The tolerances that we're going to be able to build in those types of manufacturing environments are going to be very impressive.
Yeah, yeah. I mean, historically, to use that machining analog, although it could be almost anything industrial process. Of course, we think about upper and lower
Yeah.
control limits, and how essentially is that we're measuring a parameter and watching it drift from the mean toward one of those upper or lower control limits. And as it trends that way, we integrate over time and say, okay, um, 6 hours from now, we're going to be out of spec. So let's take some corrective action right now. So we went from sort of the bang bang actuator model to one in which we're curve fitting, or kind of smoothing that curve, and we're nudging things back to the median before we get into a crisis mode. But of course, as the better we get, the closer we pull those upper lower control limits, so it gets more challenging as we go. Is That's still human set? Is AI going to turn around and say, I've done a PKA, I know the capability of this machine, and this is what you're going to get, and let me set the limits?
Well, I have to think the answer is yes,
Yeah,
right? Because that is a benefit that would make sense, right? And anything that makes sense nowadays, if we can get rid of those tolerant deficiencies,
yeah,
um, yes, it's going to happen, right?
yeah.
Um, yeah, and I think that's a good thing, right? We want to go there too. It's not like a question of if, it's a question of when.
Yeah, yeah, yeah. Mike, can we have edge computing without AI, or vice versa?
So yes, I think there is a process. There's machine learning, right? AI is a lot of that machine learning. We you can do that. I we at Digi, we have a lot of automation, a lot of containerized applications that you can run for security, like IDS, IPS for serial, right? Things that don't require a heavy lift to a data center for an AI processing point, things that will be very valuable in like rural, remote environments. Um, there is, I think there's still a need for that, for like the aggregation of sensors and pumps and gates and all the things that are in a warehouse environment, to be able to like correlate and extrapolate that from a very simple perspective to maybe a cloud environment. All of that is still very valuable. I think we'll continue to see that, from a containerized perspective. There really is the sky's the limit. We can do so many things without AI today, but it's when we start needing to process that data in those large language models, right? Putting them in an S3 bucket, put them up in Amazon, and let AI just go to town on that data. That is where what I'm seeing right now. You know, I do think there's some hardware limitations right now with AI processing. You have to spend a lot of money on processing power to get AI up to a level where it's very valuable at the edge, right? But you can do some very interesting things outside of those, that the expense of that. um, Now, all of that will change. Give it 5 years, all of that will change. We'll have better processing. AI will be more efficient. Will smaller. We'll have dedicated processors specific to AI on, say, a router, or on a computer that is separate from its processing power, like GPUs, and specific GPUs for that. I it it I mean, honestly, I love talking about this because the things that are coming, we don't even know yet, right? But it's going to be very. I get surprised every now and again by, like, my wife will use AI to go look up something, and I'm just blown away that she did that. And so the things that we use AI for, is going to change the landscape of how we go and process and manufacture and do all of these things. So it will come because it's needed. And again, solving for that, we don't have the workforce. It's a necessity. It will happen.
Yeah. Kevin, last question. It's a vital question, and that is the difference between large scale and small scale manufacturing in America is considerable. Estimates 75-80% of all manufacturing in America are SMEs. And there's always been an assumption, and generally been proven true, that advancements like automation, large scale computer control are expensive, implemented by very large companies, the Boeings and the General Motors and the Fords of the world there. But there's a yawning gap between that capability and that of the small and medium-sized manufacturer, who really are sort of the heartbeat of the entire operation. They're the key enablers there. In the future, are we going to see a more affordable solution that will allow small and medium-sized companies to actually play in the big leagues in AI and edge computing?
Yeah, 100%. I mean, there are services out there. I mean, even Digi has services that can help people scale. The thing in my particular role, is to bring in partners and an ecosystem of solutions. So, bring in the connectivity with the private 5G. Contentionless Wi-Fi is the way I like to look at it, right? So that their network and their Wi-Fi guys are baffled why Wi-Fi doesn't work. Well, there's so many reasons why Wi-Fi doesn't work in these environments, but private 5G would, right? And then to bring a Digi product in, and to bring a container that runs a specific set of tools, to automate things. Like, again, it's all about the ecosystem, and we can have that today. So, day one, when we do see these smaller guys, right? And I'll be honest with you, we're working with them today. So we're solving this today, for not the big people, right? For the big people too, but the large OEMs, but for those smaller ones, at volume, with consistency, right, at scale, we're able to kind of solve that particular challenge. And it's super fun to do that, to be able to just come up with a solution, and know that it works because you just did it for the other guy.
Manufacturing AI for everyone. It sounds awesome. Kevin Johnson, Digi International Principal Engineer, thanks for joining me in Industry Insights and Trends.
Jim, it's been a pleasure. Thank you, sir.
That's it for today's Industry Insights and Trends podcast, brought to you by engineering.com. If you like this program and want to keep pace with the latest innovations in engineering, subscribe to our newsletters such as Design Weekly, 3D printing, aerospace and defense, digital transformation, simulation, or a weekly roundup at engineering.com/subscribe. For our deeper engineering series, visit engineering.com TV for exclusive shows like Designing the Future, Manufacturing the Future, and the Engineering Roundtable, found exclusively on engineering.com TV. Thanks for tuning in.